Hey guys, here's the second review. The first problem, Jerome and Terrence are brothers and they're arguing about which one of them has to mow the lawn this week. Which option gives a fair method for determining who has to mow the lawn? And just as a kind of quick reminder, the one that gives them the equal amount of chance is best, and the one that is least biased is best. And so the one that I chose was flipping a coin. If it lands on head, then Jerome has to mow, and otherwise Terrence has to mow. So I chose this one. Alright. Number 2. In his first year after graduating from college, Bernie earns $10,000 each year. After that, he earns twice as much as he did in the previous year. What is the total amount of money that Bernie will earn in his first 8 years of college? So this is geometric because it's going to double, so your ratio is 2. And so the formula, in case you forgot, is a sub 1 times 1 minus r to the n over 1 minus r. So we're going to do 10,000 times 1 minus 2 to the 8th over 1 minus 2. When I do 1 minus 2 to the 8th power times 10,000 divided by 1 negative, I get 2,550,000. So 2,550,000. Okay, part 2. Based on the information in part 1, select all the statements that are true. What I did was, it's talking about 5 years and 10 years, and it's talking about the total. So I went ahead and I found the sum of 5 years. So that's 10,000 times 1 minus 2 to the 5th over 1 minus 2. And then I also did it to the 10th. And I compared both. So I'll do the 5,000, 1 minus 2 to the 5th power. Is negative 31 times 10,000 is 310, well, negative 310. And then divided by negative 1, you get positive 310,000. So this one's correct right here. And then I did the other one, 1 minus 2 to the 10th. Multiplied it by 10,000. And I've got 10,230,000. And those are my answers. So I use the sum formula for the geometric sequence. Alright. Next one. Sanhaya goes to a baseball game and randomly selects 3 players from the starting lineup to interview. Which of the following best describes the population represented by this sample? So she goes to the baseball game and randomly selects 3 players from the starting lineup. Which of the following best describes the population represented by this sample? All of the players on the baseball team who she likes, all of the players who showed up for the game, all of the players on the baseball team, or all of the players on the baseball team who started the game. So if she's going to randomly select 3 players out of the starting lineup, I would say that the population is going to be all of the players on the baseball team who started the game. 4. Sports researchers want to know the probability of scoring on 60 out of 100 free throw attempts. If successful and unsuccessful free throw shots have the same likelihood, which simulation would best model the situation and why? Rolling a single die 100 times and seeing how many times the number 1 comes up because the study is looking at one particular outcome. Flipping a coin 100 times and seeing how many heads come up because the probability of a successful shot is the same as the probability of getting heads. Drawing a card from a standard 52 deck 100 times with replacement and seeing how many times you get a 2 because there are 2 possible outcomes in the study. So my choice was flipping a coin because it's the same probability as missing or making a shot. So I chose this one. Alright, number 5. Benji is an aspiring artist. Every semester he takes film, photography, and theater classes. Film classes cost $167.60 each, photography $220, and theater $407. This semester he is taking film classes, photography classes, and theater classes, and his total tuition is $28.12. Write an equation. So I went ahead and did 167.60 times x, because we don't know how many film classes he's taking, plus 220.80 times y, plus 407.20 times z equals 2,812. And that's my equation. Okay. Let's move on to number 6. Alice throws a stone over a cliff, and the height of the stone in feet is a function of the amount of time that has passed in seconds since she released the stone. The graph represents the function. Select all statements that correctly interpret the graph. It's saying the initial height of the stone is 192. Yes, this right here is my initial height over here. So I'd say yes. It says the stone is in the air for a total of 2 seconds. Okay, so it starts at 0 seconds and it goes for a total of 6 seconds. So that's out. The maximum height of the stone reaches 256. So that is right there. Yes, that's your max. While we're at it, how long does it take to reach the max? 2 seconds, not 6 seconds. The stone is at a height of 128 feet after 5 seconds. We're talking right there and right there. Let me retrace to make sure I did that one right. The stone is at a height of 128 feet after 5 seconds. So this line right there. This one right. Oh, that wasn't a good one. It's hard to do with this stylus. Right there. I would say no. That at 5 seconds, it is 112 feet right here. So only those two are the ones I selected, these two. Next page. A test can be used to help determine whether a patient has a particular disease. A hospital recorded the results of administering the test to 600,000 patients and organized them in the table below. If a patient gets a positive result on the test, should her doctor conclude that she has the disease? So what I did was, it says if a patient gets positive results on the test, should her doctor conclude that she has the disease. So that would be positive results and has the disease. So 490 out of 600,000. I'm sorry, 4,900 is 0.008. So I would say no, that only about 1%, 1% of patients who test positive have the disease. Moving on. Number 8. Write an expression that's equivalent to f of x times g of x. I like to put the smaller one in front. So x plus 2 times x to the 5th plus 2x cubed plus x plus 8. So that's x to the 6th plus 2x to the 4th, x6, 2x 4th, x squared, 8x, 2x to the 5th, 4x cubed, 2x, 16. So that leaves me with x to the 6th, 2x to the 5th, 2x to the 4th, four x cubed, x squared, 10x, and 16. Number 9. Fumika and Sherry are flipping a coin. Fumika flips the coin 40 times and gets tails 18. And Sherry flips it 20 and gets tails 11. After this, Fumika says that she wants to go to the movies, but Sherry would rather go bowling. Fumika suggests that they flip the coin one more time to decide. If it comes up heads, they will go to the movies, and if it comes up tails, they will go bowling. Is this a fair method for Sherry to agree to? Why or why not? And you would say, is it a fair method because it leaves the decision up to chance? Is it a fair method because the coin appears equally likely to come up heads or tails? Is it a fair method because the coin is now more likely to come up tails? No, not that one. It is not a fair method because the coin does not seem to be... No. Neither one of those. So you have to choose between deciding, is it a fair method because the coin appears equally likely to come up heads or tails? Or is it because you're leaving it up to chance? And what I chose, the second one because the chances of it being heads or tails is 50%. Alright. What are the solutions to this quadratic equation? This one gave few of us a problem, or some of us. So I used the quadratic formula. So that'd be negative b, so that'd be 4 plus minus b squared minus 4 times a times c over 2 times a. If you do the math underneath, that would be 16 minus 4 times 4 times 25. You get negative 384 4 plus minus negative 384 over 8. I could tell that something went into it from looking at my answers, and I can tell that a 6 went into it. So when you divide 384 by 6, it gives you the perfect square we're looking at, which is negative 64 times 6. Remember, the square root of negative 64 is 8i. Leave the 6 under. You can also tell they separated their answers from the complex or the imaginary part. So I'm going to go ahead and do that right now, actually. Separate it. And what I mean is, instead of putting the whole thing over 8, they just separated it like this. So 4 over 8 is 1/2 plus minus. These two 8's cancel out. And you're left with I root 6, but they wrote it as 6 and then the I on the outside. So then your answer ends up being this one right, not that one, sorry, this one right here. The second one. Alright, number 11. Select all the expressions that are equivalent to 26i plus 23i. Alright, so I went ahead and combined like terms. 26i plus 23i is 49i. I could look at this one right here and I automatically see that it's 49 times the square root of negative 1, which is 49i. Negative 49i and positive 49i are out. 7 squared I is the same thing as 49i, so that's in. The one that's probably tricky is this one up here, because you'll see that because the negative 7 is not in parentheses, that'll equal negative 49. And you'll think, okay, that's 49i, but the square root of negative 49 is actually 7i. Alright, this next one. What's the simplified quotient? It looks like a really difficult problem, but if you look at every single one of these, you're going to see that they all simplify to negative 2/3. Which of the following values are x solutions? Of x are the solutions. So they must have done completing the square. You have to remember that when you do the square root, you get plus minus 5. Subtract 4. Negative 4 plus minus 5 is going to be 1 and negative 9. So 1 and negative 1. Select all of the functions that have a domain of x is less than equal to negative 1 and x is greater than negative 1. Okay, so select all the functions that have a domain of x is less than negative 1 and x is greater than equal to 1. So if you look at the very first one, x minus 1 has to be greater than or equal to 0 because you don't want a negative number underneath there. That's how you find the domain. So then x has to be greater than or equal to 1. The next one, x squared minus 1, has to be greater than or equal to 0. When you do, you get x squared is greater than or equal to 1. But when you do the square root, remember that it's plus minus 1. And so you're also, when you're dealing with a negative, I don't know if you remember, but you're going to have to flip your sign. So you're going to have one that is positive 1 and one that is negative 1. So another way you can check it is, if you're wondering if it can be, let's say, plug in negative 2. If you plug in negative 2 here, you would get 4 minus 1 is 3. That's okay. Alright, so this one, you're going to end up getting x is less than or equal to negative 1, and x is greater than or equal to 1, so this is a yes. If you do the cubed one, you would add 1, but then you take the cube root, you'd only get one answer. If you do the fourth root, you'd add 1, you take the fourth root, and because it's an even exponent, you'd get 2 answers. This one would be the same. So those are your 2 answers. Number 15, what's the sum? Alright, and remember, in order to add, you have to have common denominators. So the way that we learn this is we look at this one right here and we say, okay, what's missing from this one? A lot of you are going to want to say plus 1, but what's actually missing is the binomial of x plus 1. Because if you were to multiply this by plus 1, you'd still get x. You wouldn't get x plus 1. So this left side is missing x plus 1. Therefore, this right side is missing the single x. That one's tricky because a lot of people will want to say plus 1. So when you multiply the top by x plus 1, you get x plus 1. And then plus 4x. The new bottom is x parentheses x plus 1. So you actually get 5x plus 1 over x times x plus 1. That's this one right here. Number 16, what's the simplified form? Remember, I squared is negative 1, so we don't normally do that. We would normally just put it like this. Select all the values that are solutions to the equation above. Okay, well, you can multiply both sides by x plus 5, and you'll get x squared minus 4x minus 21 equals 0. The factors are x minus 7, x plus 3. If you set them equal to 0, you get x equals 7 and x equals negative 3. The restriction is negative 5, so we're good. So your answer is 7 and negative 3. Number 18, a colony of bacteria had an initial population of 500 and grows at a rate of 19%. Be careful because it grows at a rate of 19%. So that means you have to add 1 to it. So that pretty much tells us our answer so far. Krista is wondering how long it will take the population to reach 5 times its original size. And so, because normally our formula will be a sub 1 times r to the n minus 1, but I don't know if you remember, the 500 hasn't grown yet, so you're going to see down here, it's a growth problem, and you end up getting this first one right here. Be careful with the 1.19. If it grows, you got to add 1 to it. If it's decreasing, you got to subtract it from 1. How long will it take for the population to reach 5 times its initial size? Round your answer to the nearest tenth. So 2,500. You're going to solve the equation. Equals 500 times 1.19t. Divide by 500. So 5 equals 1.19t. Log them. So you got 5 log divided by 1.19 log equals 9.3. 9.25. I got 9, so then I'm going to put 9.3. Oopsie. Alright. What is a simplified quotient? Assume the denominator does not equal 0. Alright, this one's not like the last one. They don't all three. They're not all lined up, and you can't just look at them. So, we are going to, we might as well do long division. 3x minus 9. 6x squared minus 6x minus 36. No placeholders. Alright, 6x squared divided by 3x is 2x. 2x times 3x is 6x squared. 2x times negative 9 is negative 18x. When you subtract, you get that, because you got to change your signs. You get 12x minus 36. 12x divided by 3x is 4. 4 times 3 is 12x minus 36. Subtract. So the quotient is 2x plus 4. No remainder. What is the solution to the equation above? Multiply both sides by x plus 3. And you're going to get 6x minus 1 equals x plus 3. Because usually there's a 0, but there's a 1 there now. Minus x. 5x minus 1 equals 3. 5x equals 4. X equals 4 over 5. What's the domain? Remember, you take what's inside, and it has to be greater than or equal to 0. So 2x has to be greater than or equal to 4. X has to be greater than or equal to 2. It can't be a negative number, because then you get imaginary. 22. Which of the following expressions is equivalent to the following? If you do California, over here, you're looking for factors of 625 that give you negative 50. And they are negative 25, negative 25. Put 625 on top. If you reduce that, you are going to get 25h. Because it's 8, we're going to half it so that each one has 4. Minus 1 for the first one. And the second one. Alright. Then, I don't know if y'all see it, but this one is a difference of squares. So it's really going to be 5h squared minus 1. 5h squared plus 1. And this one's going to do another one. 5h squared minus 1. 5h squared plus 1. There's 2 of the minus ones. And there's 2 of the plus ones. So I chose B. 5h squared plus 1 squared times 5h squared minus 1 squared. Because there's 2 of these. And then there were 2 of those. What are the solutions of this system? You're going to want to set them equal. But you might as well get this one in standard form. Like this one. So that's x squared. I'm foiling this. I'm doing x plus 4 times x plus 4 which gives me x squared plus 8x plus 16. And I can't forget the negative 5 there, equals negative x squared minus 4x plus 1. I'm going to put everything on one side. So if I move this over, I'm going to get 2x squared. Move the 4x over, I'm going to get 12x. This equals 11, subtract the 1, I'm going to get 10. Then I'm going to set it, now the right side equals 0. So I have, I'm going to take a 2 out. Still going to factor x plus 5, x plus 1. And I'm going to set everything equal to 0. This is gone. Who cares about that? So I got x equals negative 5 and x equals negative 1. Number 25, which of the following represents this one? Remember, on the inside of the graph, you do the opposite. So you're going to go right 4, and then you're going to go down 3. Your vertex is positive 4, negative 3, and it's going down. So it's between these two, and this is the one that has positive 4, negative 3 vertex. Use synthetic division to find the quotient. Which of the following statements correspond? So if I use synthetic division, remember you got to do the opposite on the inside. So 5, no placeholders, that's good. So 3, negative 10, negative 32, 35, bring down the 3, multiply. When you add, you get 5, multiply. When you do negative 32 plus 25, you get negative 7, multiply. When you add, you get 0. It says one of the parts is negative 7 plus 32 is 25. So the quotient contains the term 25. This is our quotient, guys, right here. The final answer. So this is out. No. This next one is saying right here, negative 32 and 25 gives you negative 7, so this is one of our terms. Yes. Negative 10 and 15 give us 5. So one of my terms is 5x. I guess I should have written the 3x squared like that. There we go. So 5x is right. And then the last one, it's right here, it's saying 70. But it actually canceled out. So those are the two answers.